Hello, Professor Lohman. My name is Alberto Ramos Jr., and when taking the intelligence quiz, I got the result of a naturalist. And according to the list, I'm going to be working on the first problem on Chapter 6. So for Part A, they're asking to find the total workforce done by friction. I'm going to be drawing a free body diagram to represent the function vector. Now, since we are on an inclined plane, we have to find the x component of the friction force, which equals the weight of the block times cosine theta times the friction coefficient. We would get our friction force. Now, work is equal to force times distance, so we're going to plug in our friction force and our variable for distance, which is L. And we get the answer, which is equal to the work done by friction. And since it's in the opposite direction, the friction force is negative friction coefficient times the weight cosine theta times the distance. For Part B, we're trying to find the total workforce done by the applied force. Same as Part A, we're going to draw a free body diagram. And this one is fairly easy since work is equal to force times the distance. We're just going to plug in the applied force for the force and L for the distance, and we get our answer, which is equal to work equals force 1 times L. Part C is very similar to Part A. They're asking to find the total work done by the friction force. I'm going to be drawing the free body diagram to represent the friction vector. And since it's an inclined plane, we have to find the x component of the friction force, which is equal to the weight of the block times cosine theta times the friction coefficient. This would equal our force of friction. And to find work, we need friction and distance. We're going to plug those answers into our formula, and we get work is equal to negative friction coefficient weight cosine theta times the distance. And finally, Part D. They're asking the same question as Part C, which is find the work done by the applied force. So what we're going to do is draw a free body diagram and the force vector. Since work is equal to force times distance, we're going to plug it in, and we get our answer, which is work equals force 2 times the distance of L.